It is acceptable to use existing service entrance cable or SE cable for a subpanel installation provided certain requirements are met. The most critical aspect is ensuring that the neutral and ground conductors are completely separated within the subpanel. This separation is fundamental to proper grounding and fault current path, and it is a code requirement for subpanels. Firstly, the existing SE cable must be in good condition. This means there should be no visible damage to the outer jacket, such as cuts, abrasions, or cracking. The conductors inside should also be free from corrosion, oxidation, or any signs of overheating. Secondly, the SE cable must have sufficient ampacity to handle the loads that will be served by the subpanel. Ampacity refers to the current carrying capacity of a conductor, and it is determined by the size of the wire and its insulation type. To determine the ampacity of the existing SE cable, consult the cable's markings or refer to the National Electrical Code, or NEC, Table 310.15b16, which provides ampacity ratings for various conductor sizes and insulation types. It is crucial to select an ampacity rating that is suitable for the termination temperature rating of the equipment. For example, you cannot use the 90 degrees Celsius column if the breaker or panel is rated for only 75 degrees Celsius. Thirdly, to achieve the necessary separation of neutrals and grounds, you will typically need to install a separate ground bar and a neutral bar within the subpanel enclosure. The ground bar should be bonded directly to the metal enclosure of the subpanel, ensuring a low impedance path for fault currents to return to the main panel. The neutral bar, on the other hand, should be isolated from the subpanel enclosure and connected only to the neutral conductors. Some subpanels are manufactured with a built-in neutral ground separation barrier. These panels simplify the installation process by providing dedicated terminals for neutral and ground conductors, along with a physical barrier to prevent accidental contact between the two. Fourthly, proper bonding between the subpanel and the main panel is essential for electrical safety. Bonding ensures that all metallic parts of the electrical system are at the same electrical potential, minimizing the risk of electric shock. The subpanel should be bonded to the main panel using a grounding conductor that is sized according to the NEC Table 250.122, based on the overcurrent protective device protecting the circuit feeding the subpanel. The grounding conductor should be connected to the ground bar in both the subpanel and the main panel. Using the existing SE cable can offer several benefits. Firstly, it can save time and labor by eliminating the need to run new cables. This is particularly advantageous if the existing cable is in a difficult-to-access location or if running new cables would require extensive demolition and reconstruction. Secondly, reusing existing infrastructure can reduce costs. New cables, conduits, and associated hardware can be expensive, so utilizing the existing SE cable can result in significant savings. Thirdly, maintaining the original wiring configuration may be preferred for aesthetic or historical reasons. In some cases, preserving the original appearance of the electrical system is important, especially in older buildings or historic properties. However, it is crucial to exercise caution when using existing SE cable. Firstly, it is imperative to verify the ampacity of the existing SE cable before using it for the subpanel. Overloading the cable can lead to overheating, insulation damage, and even electrical fires. If the calculated load exceeds the cable's ampacity, you must either reduce the load or replace the cable with one of a larger size. Secondly, if the SE cable is damaged or has insufficient ampacity, it must be replaced. Do not attempt to repair damaged cables, as this can compromise their integrity and create a safety hazard. Instead, replace the entire cable with a new one that meets the current code requirement and has adequate ampacity for the intended load. Furthermore, if the existing SE cable is aluminum, special precautions may be necessary. Aluminum conductors can corrode over time, especially at connections. When connecting aluminum conductors to the subpanel terminals, use an anti-oxidation compound specifically designed for aluminum connections. This compound will help prevent corrosion and ensure a reliable electrical connection. It is also important to use connectors that are rated for use with aluminum conductors. These connectors are typically made of aluminum or have a special coating to prevent galvanic corrosion between the aluminum conductor and the connector. Always torque connections to the manufacturer's specification to ensure a robust and safe connection. Also, consider the voltage drop on long runs to ensure acceptable voltage levels at the subpanel. In general, voltage drop should not exceed 3% for branch circuits or 5% for feeders. Using existing SE cable to feed a subpanel is an acceptable practice if you follow the NEC and good workmanship practices.